Hello friends, welcome back in lecture number 5 about the basic concepts of fluid mechanics. In this lecture, in last lecture we have discussed about some basic entities related with fluid mechanics. That is, we have discussed related with how units of area is defined, how units of velocity is defined, etc. In today's lecture we are going to discuss about basic concepts of fluid mechanics, in which we are going to discuss about different another unit entities, for example acceleration, in pressure, and etc. So in a conversion of acceleration, what is meant by acceleration? Acceleration is nothing but velocity per unit time. And what is nothing but the velocity? Velocity is nothing but distance per unit time. So I can write acceleration as acceleration is equals to velocity by time, and velocity is nothing but length by time. So unit of acceleration can be defined as length by time square. So unit of length in MKS unit is meter and time is second. So it will become meter per second square. Now convert acceleration of 75 feet per hour square into meter per second. Okay, so this is conversion of British unit system to the SI unit system. So we know that 1 feet is equals to 30.48 centimeter. So, and again centimeter can be converted into meter by dividing by 100. So 1 feet is nothing but 30.48 divided by 100 is equals to 0.3048 meter. So 1 feet is nothing but 0.3048 meter. So here we'll convert feet into meter and hour into second. So we know that 1 hour is equals to 3600 seconds. So it can be written as 75 feet per hour square is equals to 75 into 0.3048 divided by 2600 bracket square. That is 75 into 0.3048 divided by 3600 square. It will give output as 1.76 into 10 to the power minus 6 meter per second square. Okay, so here 75 feet per hour square acceleration is nothing but 1.76 into 10 to the power minus 6 meter per second square is the acceleration. Similarly, force. What is force? Force is nothing but mass into acceleration. Mass into acceleration. Or in a definition point of view, we can say that force is nothing but change in speed. When the force is applied on the body, there is the change in its initial motion or initial position. It is nothing but the force. So mass into acceleration is nothing but mass into velocity divided by time. Again, mass is the basic entity, time is the basic entity. Velocity can be written as length divided by time. So it would be mass into length by time into 1 by time. Mass unit is meter, length by time into time square. So it can be written as mass into length divided by time square. So mass in kg, length in meter, and time in second square. So force can be given as kg meter per second square. Kg meter per second square. And we know that 1 kg meter per second square is nothing but 1 Newton. 1 kg meter per second square, it is nothing but 1 Newton. Okay. Now in SI system, 1 Newton is equals to 1 kg meter per second square. In CJ system, 1 dyne is equals to 1 gram centimeter per second square. So 1 Newton by 1 dyne is equals to 1 kg by 1 gram, 1 meter by 1 centimeter, 1 second by 1 second bracket square. So it is nothing but 1000 gram divided by 1 g, 100 centimeter divided by 1 centimeter, and 1 second by 1 second. So all units will be gets cancelled. So we can say that 1 Newton divided by 1 dyne is equals to 10 to the power 5. Or in short, I can say that 1 Newton is equals to 10 to the power 5 times dyne. Okay, so this is about the conversion of forces. See here once again, 1 Newton divided by 1 dyne is equals to 1 kg by 1 gram, 1 meter by 1 centimeter, and 1 second by 1 second bracket square. For the cancellation of unit, we are going to convert kg into gram. meter into centimeter, and second will be as it is. So second will get cancelled, centimeter gets cancelled, g gets cancelled, remaining is 1000 by 100. Sorry, 1000 into 100. So 1 Newton is equals to 10 to power 5 dyne. Okay. Now for example, we will take one example. Convert force of 33 dyne into Newton. Now we know that 1 Newton is equals to 10 to power 5 dyne. So 33 dyne is equals to how much Newton? So it can be given as 33 divided by 10 to power 5 dyne. 33 divided by 10 to power 5 dyne, and it will be equals to 33 into 10 to power minus 5 Newton force. Now take another example. Convert force of 54 lbf into Newton. So lbf is nothing but the unit of pound. Okay, so I can say convert 54 pound into Newton. So pound can be converted as, or lbf can be converted as 1 pound into gravitational force into meter per second square. So 1 pound is nothing but 0.45 kg. So 1 lbf is nothing but 0.45 into 9 to power 9.81 kg meter per second square. But kg meter per second square is nothing but Newton. So therefore 1 lbf is equals to 4.41 Newton. Okay. So by using this formula, can we convert 54 lbf into Newton? So 54 lbf is nothing but 54 into 4.41. It is equals to 238.14 Newton. This is similarly we are able to calculate the pressure force also. Pressure also. What is pressure? Pressure is nothing but force per unit area. So force is given in a Newton and area in meter square. So pressure, unit of pressure is Newton per meter square. So pressure is also expressed in Newton per meter square, in PSI, that is pound force per square inch, and PSI can be given as lbs per inch, that is force per inch, or kg per centimeter square. Now we will take an example. Convert pressure of 54 psi lb per inch square into Newton per meter square. Now pressure is 54 psi, so it is nothing but 54 lb per inch square. But we know that in previous only we discussed 1 lbf is equals to 4.41 Newton. So that we are going to use that here. So again put lb is equals to 0.54 kg, inch is nothing but 2.54 centimeter. So it is 54 into 0.45 divided by 2.54 bracket square. So it will use as 3.766 kg per centimeter square. So for conversion of kg per centimeter square to Newton per meter square, again we know that kg to Newton is nothing but 1 kg is equals to 9.81 Newton. So and we wanted to convert centimeter into meter, then the centimeter requires to be divided by 1000. So it can be 100. So it can be written as 3.766 into 9.81 divided by 100 square. So it would be 3.766 into 9.81 into 100 square. So finally the answer is 0.369 into 10 to power 6 Newton meter. Okay, this is about the conversion of pressure. Again we will take one more example. Convert pressure of 49 psi into Newton per meter square. Okay, now 49 psi is nothing but 49 lb per inch square. So 49 into 0.45 divided by 2.54 square. How 0.45 comes? 1 pound is equals to 0.45 Newton. So 49 lb is equals to 49 into 0.45 Newton, and inch, 1 inch nothing but 2.54 square. So sorry, 2.54 centimeter. So inch square is nothing but 2.54 centimeter square. Okay, so the 49 psi is converted into Newton per centimeter square by multiplying it with 0.45 and dividing it with 2.54 as a constant for the mass and for the distance respectively. Okay, so it becomes 3.417 kg per centimeter square. For conversion of kg per centimeter square to Newton per meter square, again as like in a previous one, 1 kg is nothing but 9.81 Newton. So for converting kg into Newton requires to multiply by 9.81, and again for conversion of centimeter square to meter square it is requires to divided by 100. So 1 centimeter square is equals to 1 upon 100 square meter square. Okay, so I can write this as 3.417 into 9.81 divided by 1 divided by 100 square. So it becomes 3.417 into 9.81 into 100 square. So it becomes 335.335 into 10 to power 6 Newton per meter square. Okay, so this is about the conversion of pressure. Now we'll move further for the work. What is work? Work done is nothing but force into distance. Energy expenditure can be given as force into distance. Now what is the unit for force? Force is measured in a Newton, and distance is measured in a meter. Okay, so energy can be given as Newton meter, which is also known as joule. Work and energy, these are two scalar quantities, and that can be measured in SI system by joule, and 1 joule is equals to 1 kg meter square per second square, and in CJ system it is measured in ergs, so it is G into centimeter square by second square. So 1 joule is equals to 1 kg meter square per second square. So kg meter per second square into 1 meter is nothing but 1000 gram into 100 centimeter into 100 centimeter divided by second square. So 1 arch is equals to, because 1 arch is nothing but 1 g centimeter square second square, so it becomes this much gram centimeter square per second square. So 1 joule is equals to 10 to power 7 ergs. Okay, again in energy and force conversion, therefore we can write as 1 joule is equals to 1 kg meter square per second square, 1 erg is equals to 1 gram centimeter square per second square, and 1 joule is equals to 10 to power 7 ergs. Now convert 20 joule into dyne per centimeter. How to convert? 1 dyne is nothing but 1 gram centimeter per second square, and 1 dyne centimeter is equals to 1 gram centimeter square per second square. But we know that 1 gram centimeter square second square is nothing but 1 erg. So, and 1 joule is equals to 10 to power 7 ergs. Therefore 20 joule can be converted as 20 into 10 to power 7 erg or dyne centimeter. Similarly, convert 15 Newton meter into erg. So 1 Newton meter is nothing but joule is nothing but 10 to power 7 ergs. Therefore 15 Newton meter is equals to 15 into 10 to power 7 ergs. Again 15 foot pound requires to be converted into Newton meter. So 15 foot pound is nothing but 1 pound is nothing but 0.45 kg, and 1 feet is equals to 30.48. So it is 15 into 0.45 into 30.48 into 9.81 divided by 100. So 9.81 is for conversion of kg into Newton and divided by 100 for centimeter to meter. So 15 foot pound is nothing but 20.183 Newton meter. Similarly, for energy conversion purpose, convert 15 joule into kilojoule. So 1 kilojoule is equals to 1000 joule. So 1 joule is equals to 1 by 1000 kilojoule. So 15 joule can be written as 15 into 10 to power minus 3 joule. Now we will move further for the power. So what is power? Power is nothing but work done per unit time, or power can be given as work divided by time. So formula for work is Newton meter and for time it is second. So power can be given as Newton meter per second, but Newton meter is nothing but joule. Newton meter is nothing but joule and divided by time is second, and joule per second is also known as in a watt with the name of scientist. So it is expressed in watt or joule per second or Newton meter per second. Now 1 hour is equals to 3600 seconds. We wanted to convert 81 joule per hour into watt or joule per second. So with 81 joule per hour, it can be equals to 81 divided by 3600. So it is equals to 0.0225 joule per second or watt. Okay. Similarly, convert 43 joule per minute into watt. Again, minutes requires to be divided by 60. So 43 joule per minute is nothing but 43 divided by 60. It is nothing but 0.71 joule per second, or it is also known as watt. Now convert the power of 55 foot pound per minute into watt. See, now here foot is the unit of distance, then next is pound is nothing but unit of weight, and minute is unit of second. So foot, pound, minute is required to convert into Newton meter per second. So how to convert foot into Newton? So we know that how to convert pound into Newton? So we know that 1 pound is equals to 0.45 kg. So pound can be converted into Newton as multiplying by 0.45 into 9.81, because multiplying by 0.45 it will be converted to kg, and multiplying by 9.81 it will be converted to Newton. Okay. Similarly, 1 feet is nothing but 30.48 centimeter. 30.48 centimeter. We have to convert it into meter, but 1 centimeter is nothing but 100. So 1 feet is nothing but 30.48 divided by 100 meter, and time in minute is nothing but 1 minute is equals to 60 seconds. So in calculations we can write this as 55 into 0.45, which is multiplied by pound gets converted into kg, into 9.81 it is converted into Newton, into 30.48 so that foot is converted into centimeter, divided by 100 so that foot is converted into meter, and into 60 is nothing but time is converted into second. So the final answer is conversion of units, and it is equals to 1.23 joule per second, or we can say 55 foot pound per minute is nothing but 1.23 watt. So here we are going to conclude the chapter of this unit conversion. Actually I conducted nearly about 3 lectures for the unit conversion purpose. It is very much essential and important to understand the basic units, because various times students gets confused related with what is joule, what is watt, what is the relationship between joule and watt, what is the relationship between Newton and joule, because we are not studied these things in detail. I think we have cleared here in more detail, as well as we have taken due care of conversion of SI units and local units, that is units of British standards, units of FSI French standards. Okay, So once again I will smooth a small revision I will take. 1 mile is nothing but 1.6 kilometer. 1 yard is nothing but 3 feet. 1 kilometer is nothing but 1000 meter. 1 meter is equals to 100 centimeter. 1 centimeter is equals to 10 mm. 1 inch is equals to 2.54 centimeter, and 1 foot is equals to 30.4 centimeter. This is about the conversion of length. Similarly, we have seen for the masses, 1 kg mass is nothing but 1000 grams. 1 pound mass is nothing but 0.45 kg. As far as volume concern, 1 liter is equals to 1 into 1 by 1000 meter cube, and 1 liter is equals to 1000 centimeter cube. So here in this lecture we have discussed about unit conversion for velocity, acceleration, force, pressure, energy or work done, and power. All those entities are very much essential for the calculation of all those entities are very much essential for calculation of different fluid properties. See why unit conversion is plays an important role, because if you are failed to convert the units, then you will not be able to solve the problem even though you know the techniques. For example, in a problem, if the given power is mentioned in terms of watt and requires to calculate the force in Newton, then in that case you must know about the unit conversion, what is the relationship between watt, joule and Newton. Then and then only it can be possible to you to convert the watt into Newton, or power can be calculated. From the power, work done can be calculated. Okay, so similar type of problem solving purpose, unit conversion plays an important role. By end of this lecture, I declare that unit conversion part is over. In next lecture, we are going to start the actual syllabus of fluid mechanics, which is set by the D Batu for academic year 2021. In this lecture, we have taken the review of velocity, acceleration, force, pressure, energy and work done, and power. All those entities. After the end of this lecture, you are able to I think now you are able to solve the problem of acceleration, force, pressure and energy, as well as you are able to convert the units according to the requirement. Okay, so in the next lecture we will meet with the actual syllabus. Thank you.